Okay, so I'm looking at calculus right now. So we're going to have a test on Tuesday. And I said that today would be a review. And I would go over homework. I've already gone over a couple of questions out of 6.7, but a few people asked me some other ones. So basically, what I'm going to try and quickly do is go over the other ones besides 3 and 7a, because those are the ones that I did. So that would be 1, 2, 4, and 6. And then there was a couple of questions out of the other homework. Wicket, come lay down, please. There was a couple of questions out of the other homework. No, that's the wrong direction. Go that way. Go right. Go right. Okay. So, number 1 says, oh yeah, he's going to come to you. Good luck with that. He's going to play. Where'd he go?
Kevin.
Hi. Okay.
Come on, let's go.
All right. So dogs have been taken away from me now. So suppose that R is equal to M plus N, and M times N is 1,000. It says find the value of M that minimizes R. So I'm trying to minimize this. So that is what I'm going to end up taking the derivative of. But again, I cannot have 3 different variables in a question. So that's why you have this, so that you can rearrange it. M equals 1,000 over N. Now you could just as easily say N is 1,000 over M. It doesn't matter. And I'm going to replace that here. Instead of putting M, I'm going to put 1,000 over N plus N. Now I'm going to write that as 1,000 N to the negative 1 plus N, and then I'm going to find the derivative. So if I bring the negative 1 down, that's going to be negative 1,000 N to the negative 2 plus 1. So I'm going to make it equal to 0, and that's negative 1,000 over N squared plus 1. So if I move this over here, I have negative 1 is equal to negative 1,000 over N squared. So negative N squared is equal to negative 1,000. So N squared is 1,000. So N is the square root of 1,000. And the square root of 1,000 is 31.6. That's the N, but they said find the value of M. So M is 1,000 divided by 31.6, which is 31.6. So the value of M is 31.6. That's number 1. Number 2. It's harder to erase purple. Number 2 says if K is equal to PQ and P minus Q is 1,500, find the value of P that makes K a minimum. So K is a minimum. So that means that's what I'm going to be finding the derivative. But again, I have 3 different variables. Can't have that. So I'm going to move the Q over so that I have 1,500 plus Q. That's what P is. So I'm going to substitute. P is 1,500 plus Q times Q. So K is 1,500 Q plus Q squared. So the derivative of that is 1,500 plus 2Q. So I'm going to make that equal to 0, and I'm going to have negative 1,500 is equal to 2Q. So Q is 1500 divided by 2 would be what, like 750? So Q is negative 750. And they wanted to know, find the value of P. Well, P is 1500 plus negative 750. So P is 750. So whatever it tells you to maximize or minimize, that's what you're going to find the derivative of. And the other one is the one you're going to use to isolate a variable. Number 4, I know what you didn't get in number 4, I'm pretty sure. So number 4 says you have a rectangular backyard playpen for a child and you have 16 meters of fencing to make it. What dimensions of the rectangle will provide the maximum area? So area is what I'm trying to maximize. An area of a rectangular playground is length times width. So we have 16 meters of flexible fencing. That's perimeter. Perimeter is 2 lengths plus 2W in a normal rectangle, and that's what we have. We're going to make a rectangle so that little baby can be safe inside his little playpen. So I want to maximize this, but again, it's got too many variables. That's why we have this. Perimeter, I have 16 meters of fencing. So if I move, say, this over here, I have 16 minus 2W is 2L. If I divide both sides by 2, I have 8 minus W is L. So when I come over here, I can replace L with 8 minus W times W. So area is 8W minus W squared. So I want to maximize it, so I'm going to find the derivative, which is 8 minus 2W. So make that equal to 0. So 2W is 8. So W is 8 divided by 2, which is 4. So if that's 4, then L is 8 minus 4, which is 4. And I said before, if you just have a regular 4-sided rectangle, to maximize space, you're going to want to make it a square. That's why it came out to be 4 by 4, because that's a square. Now, it doesn't always come out to be a square because it's not always a full rectangle where you've got all 4 sides. Number 6, a rectangular garden plot requires an area of 32 square meters for the vegetables that you want to plant. So you need an area of 32 square meters. An area is length times width, so you have 32 is length times width. What dimensions of the plot will use the least amount of fencing to enclose the garden? So again, the perimeter is going to be, you've got 2 W's and 2 L's. So perimeter is 2 L's plus 2 W. This time you want to minimize the amount of fencing that you need in order to make this garden plot. And you need to put fencing around it so the stupid deer don't get into it. And so again, since I want to minimize the amount of fencing I need, I want to minimize the perimeter, which means I need to do the derivative of this. But again, too many variables. So it doesn't matter which one you isolate. 32 over L is W. So my perimeter then is 2L plus 2 times 32 over L, so that I only have L's on this side. So this is 2L plus 64L to the negative 1. 2 times 32 is 64, and I just brought the L up. So that's my perimeter. So I'm going to do the derivative, which is going to be 2. And bring the negative down, so negative 64L to the negative 2, which I would write as over L squared. So I'm going to make that equal to 0. So if I make that 0, I'm going to take this whole thing and move it over. So I have 64 over L squared is equal to 2. So I'm going to multiply both sides by L squared. So I'm going to have 64 is equal to 2L squared. I'm going to divide both sides by 2. So I'm going to have 32 is L squared. So L is going to be the square root of 32. So the square root of 32 is 5.7 when I round it off. And so that is my L. So if I want to find my W, I'm going to do 32 divided by that 5 point whatever. So 32 divided by my answer is also 5.7. Again, if you are putting fencing on all 4 sides, a square is the most economical shape. All right, so that was the homework on that page. I had already gone over the other questions in the other video. The other questions so far that I have on the business side of things, I didn't ask you very many questions in that section. I only asked you 1A and B and 4. And someone said 1A, they got the right answer but with the wrong sign, and they wanted to know why that sign was off, so let's figure that out. And then they had a problem with number 4. So 1B, they want, for a given cost and demand, find a production level that will maximize profit. Okay, so profit is revenue minus cost. In B, they tell you that the cost is really long, 500 plus 5x plus 0.01x squared, and they tell you that the price is 10. So that means that the revenue is the number I sell times the price. So revenue is 10x. So my profit then is my revenue, which is 10x, minus, and you have to remember that you're subtracting this whole thing. So minus 500 plus 5x plus 0.01x squared. So profit is negative 500. 10x minus 5x would be plus 5x minus 0.01x squared. Watch your signs there. If you forget that that negative's in front of the whole thing, that will throw off your sign. So that could be it. Now I'm going to find the derivative, which that would be 0. This would be 5 minus 0.02x. I'm going to make it equal to 0. So I have 0.02x is equal to 5. So I'm going to do 5. I have fuzzies on me. 5 divided by 0.02. And I get 250. So my production level, the number that I should make, is 250 in order to maximize my profit. All right. Number 4. See what number 4 says. Number 4 says, a textile manufacturer uses regression, that's just a business term, to determine that the cost of producing X meters of woven fabric, so the cost to produce this fabric is 100 plus 8x minus 0.1x squared. Oh, and it keeps going, plus 0.001x cubed. That's lovely, nice and long. It forecasts that it can sell the fabric for a price of 16 minus 0.03x dollars. Determine the production level that will give a maximum profit. So again, profit is revenue minus cost. I don't have a revenue, but revenue is the number I sell times the price I sell it for. So my revenue is 16x minus 0.03x squared. So my profit is my revenue, 16x minus 0.03x squared, minus, and again I'm going to put this whole thing in brackets, 100 plus 8x minus 0.1x squared plus 0.001x cubed. That's fun. All right, so if I simplify this, I'm going to put it in descending order just because I like it better that way. So negative 0.001x cubed, that's that. Negative 0.03x squared minus negative 0.1, so really plus 0.1. That is plus 0.07x squared, so that's that. Excuse me. And then I have 16x minus 8x, which would be plus 8x, and then I have minus 100. So there's my profit formula. Now I want to maximize that. So the derivative. Bring my 3 down, negative 0.003x squared, plus bring the 2 down. Now you'd think I could do that in my head. I think it's 0.14, yeah, 0.14x plus 8. Now you either have to, we're going to make that equal to 0. So you either have to try and factor that, which for me ain't going to happen, or I have to do the quadratic formula. So my A would be negative 0.003, my B would be 0.14, and my C would be 8. So negative B plus or minus the square root of B squared minus 4 times A, so negative 0.003 times C, which would be 8, all over 2 times A, so 2 times negative 0.003. Now that's just gross. So 0.14 squared plus 0.003 times 4 times 8. So I get negative 0.14 plus or minus the square root of 0.1156 all over 2 times 0.003 all over negative 0.006. So if I do negative 0.14 minus the square root of 0.1156, and then I divide it by negative 0.006, I get 80. And if I do the other way, negative 0.14 minus the square root of 0.1156, and I divide it by negative 0.006, I also get 80. So the production level should be 80. And that's how I would do that one. All right, so let's talk about a review. Although you really have the videos you can go back and look at. So I'm not going to sit and go through how to do everything again, because one of the only bonuses, one of the only benefits of learning this way is you can watch how to do something anytime, because I don't take those videos down, I just leave them up there. So bonus, next year if you have to take calculus at university and you forget how to do something, you can look it up. So I'm just going to make a list of the things that we did in here, but they really built on one another. Like if you can do section 6.6, you can do 6.1 to 6.5 because it's all in there. So in section 6.1, we just talked about where is something increasing and where is something decreasing. So all we did was found the first derivative, made it equal to 0, and then said, is it positive or is it negative? If it's negative, it means it's decreasing. If it's positive, it means it's increasing. Section 6.2, we just built on that a little bit, and we talked about local maximums, local minimums, absolute maximums, and absolute minimums. So really the only difference was once you find your first derivative and make it equal to 0, let's say your critical numbers were -2 and 5, and let's say before -2 it was increasing, then it was decreasing, then it was increasing. You know that's a local max and you know that's a local minimum. That was really what we talked about there. Then we went into section 6.3, where we started talking about, is it concave up or concave down? So we would be talking about the second derivative. And if it's positive, that means it's concave up. If it's negative, that means it's concave down. And wherever it changes, that's called a point of inflection. Then in section 6.4, that's where we started talking about asymptotes. So in section 6.4, we talked about vertical asymptotes. Vertical asymptotes are just when you have a fraction, what value of x would make the denominator 0? What value of x would make the denominator 0? That's where your vertical asymptote would be. So we really just talked about vertical asymptotes, and we talked about it. We used the language of limits, but it doesn't change what we know about vertical asymptote. It's just the language that we used is different. So when you know where your asymptote is, what are you approaching as you approach the asymptote, and that is your limit. So if you have an asymptote at x is -2, and it's going up on both sides of that asymptote, then your limit as x approaches -2 is infinity. Again, you can go back and watch these videos, which is the bonus. Section 6.5, we talked about horizontal asymptotes, and if the degree on the bottom is bigger than the degree on the top, then there's a horizontal asymptote at 0. If the degree on the bottom and the degree on the top are the same, then we take the leading coefficients, the coefficients out in front, and that is where your horizontal asymptote is. And if the degree on the top is exactly one more than your degree on the bottom, that's when you have an oblique asymptote and you have to divide the bottom into the top. Again, if I ask you to do anything with oblique asymptotes, it will just be find the equation of it and maybe put the asymptote on a graph, but I won't be asking you to graph the entire thing. And then in 6.6, that's where we put it all together. If I give you a linear equation and just say, sketch the curve, give me local max, local mins, points of inflection, it really is putting it all together. Same thing if you have a fraction. It's putting it all together, finding where all the asymptotes are, figuring out what's going on near those asymptotes so you can give me a picture of what that graph looks like. Then we went into section 6.7, which was optimization problems in terms usually of area and perimeter. And then in the next section, the one you just finished, it was in terms of business. That really is what this is. Each section really builds. So if you can do the last few sections, you can do the first few sections. So just read the questions when you do the test. Make sure that you answer what I actually ask for. Your test will be on Tuesday, May 12th. Our class time is usually 2 to 3. I'm okay with it being then 2 to 3 works for me. If you guys wanted to get that done earlier, I know for instance, Olivia, you're working. If everybody was okay with doing it earlier in the day, if it didn't interfere with anybody else's classes, I would be open to that as well. You can message me, talk to me on Google Hangouts. Google Hangouts is probably the easiest because then everybody can see. and we can kind of discuss if you would like it at a different time. If not, then it'll just be the 2 to 3, but it doesn't make any difference to me. I'm just, if you want to be done and have it out of the way earlier in the day, I'm okay with that too. All right, so enjoy your day off tomorrow. Monday will be a study day. If you have any questions, you can let me know, but you'd have to let me know before Monday if you want me to make a video about it. You would have to let me know before Monday. I can't on Monday afternoon make a video. It takes me like an hour to make the video and then another 2 hours to upload it where I am because of the internet the way it is. So it's not a fast process. I usually finish uploading videos at about 11 o'clock at night, okay? So you can't let me know last minute, all right? So I will talk to you later. Have a good long weekend.